Hi everyone, welcome back to Chem Help ASAP. So have you ever had a really large number with lots of zeros at the end? Or a really small number with lots of zeros at the beginning? Who has time to write out all these zeros? Or maybe you're like me and your hand starts to cramp up after a while. Well, there is an easy way to write either these really large numbers or these really small numbers without having to write all of these zeros. And that is scientific notation. Let's take a look.
Scientific notation has a specific set of rules. There can only be one digit to the left of the decimal, and it must be a non-zero number. All of the numbers in scientific notation are significant. This includes any zeros. If you have a positive exponent, you are going to move the decimal right. You are multiplying by a power of 10. If you have a negative exponent, you are going to move the decimal left because you are dividing by a power of 10. You can also think of this as large numbers will have positive exponents, while very small numbers will have negative exponents. Let's take a look at some numbers written in standard notation and convert them into scientific notation. Here is our first example. It's a rather large number. The first thing we need to decide is where we're going to put our decimal point. Well, we need to have one non-zero digit to the left of the decimal, which means our decimal point is going to have to be right here. So the first part of my scientific notation is written like so, 1.375. Now I need to figure out what power of 10 I need. How many places did that decimal move? Well, if it started here, let's count it up. 1, 2, 3, 4, 5, 6, 7 places. So the second half of my scientific notation is 10 to the 7th. Positive exponent means I had a large number, so it's always nice to do just a logic double check. What about this number here? This isn't a very large number, but can we still write it in scientific notation? Yes, of course we can. Let's first decide where the decimal is going to be placed. Since I have to have one non-zero digit to the left of the decimal, my decimal point is going to go right here. So the first part of my scientific notation is written as 1.5. Now, how many places did I move that decimal? Well, I started here and I went 1, 2 places. So I'm going to have times 10 to the second. Again, positive exponent, larger number. Let's do one more with a positive exponent. Here is my number. Where is my decimal going to go? It's going to go right after the 6 here. So here is how I write the first part of my scientific notation. What I want to point out is I have not actually lost any digits. So if you look at the first two examples, we lost these trailing zeros when we converted into scientific notation. For this example here, we have no trailing zeros. We actually end in a non-zero digit. So I must carry all of those digits into the first part of scientific notation. These zeros in here are called captive zeros, and they must be included. They are significant. Now let's see how many spaces I moved my decimal. So I started here and I moved 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So here is the second half of my scientific notation. When writing scientific notation, it is important that you understand the difference between a zero that is a significant figure and a zero that is non-significant. But let's see some numbers with a negative exponent. I'm going to keep my rules up because I find that is very helpful. Let's take a look at our first example. Okay, so we have a rather small number here with quite a few leading zeros. Let's find where I am going to put my decimal. I'm going to put it between the 3 and the 6 here. So the first part of my scientific notation is simply 3.65. Then I need to count up how many places I move the decimal. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the second half of my scientific notation is 10 raised to the negative 10th. I used a negative exponent here, 1, because this is a small number, and also because if I'm going from scientific notation here back to the original decimal, I am moving to the left. Here is our next example. Again, we have a very small number, so we are going to be using a negative exponent. Let's put our decimal in place. We are going to be between the 4 and the 7 right here. So this is the first part of my scientific notation. Now, why did I keep this 0 here? That is because that 0 is a significant figure. It is to the right of a decimal, and it is also to the right of a non-zero digit. But I ditched all these leading zeros because they are not significant zeros. Now let's figure out how many places I moved the decimal. I went 1, 2, 3, 4. So here is the second half of my scientific notation. Again, it is to the negative fourth because to go from this place back to our original decimal, we're moving left. Let's go for a really tiny number. Here we go right here. Check out all of those zeros. Now, we need to be careful that we keep all of the zeros that are significant and get rid of all the zeros that are not significant. In this example, these zeros here in the middle are captive. They are significant. This 0 at the end is also significant, just like this one was over here. It's to the right of the decimal, and it is also to the right of a non-zero digit. These zeros up here, these are leading zeros. They are not significant. So my decimal point is going to go right after the 3, right here. And the first part of my scientific notation looks like this. Now, how many places did I move that decimal point? 1, 2, 3, 4, 5, 6, 7. So the second half is 10 to the negative 7th. This example I purposely made tricky because I wanted to show lots of captive zeros and also still a 0 at the end that is significant. Okay, but what if we have a number that looks like this? This kind of number is usually written as a decimal point. It's not usually converted into scientific notation. But does that mean we can't convert it into scientific notation? No, of course, we can convert any number into scientific notation. We follow the exact same rules. My decimal point is going to have to move between the 1 and the 2. So the first part of my scientific notation looks like this. Again, I kept this 0 because it is significant. How many places did I move that decimal point? Well, I just moved it 1. So the second half looks like this. You can see why we usually write these decimals as just decimals instead of converting into scientific notation. We haven't saved ourselves a lot of effort with this conversion here. However, if you go back and look at this first example, we did save ourselves quite a few zeros there. There's one more example that I want to show you. This one is a little bit of a trick. How would we convert this number into scientific notation? The problem we immediately run into is, well, the decimal is already in the correct position. We do not have to move it left or right. Okay, so this is the first part of our scientific notation right here. For the second half, we would say we moved the decimal 0 places. So this would be times 10 raised to the 0. Now, if you remember your rules on exponents, anything raised to the 0 is 1. So in essence, what we have written is 3.75 times 1, which is 3.75. This one is a little bit of a trick, but I always like to show that you can convert any number into scientific notation. So let's do the reverse now. Let's take a number that is already in scientific notation and convert it back into standard notation. Here is our first example. This 10 cubed, or 10 to the third, means I am going to take this decimal place and move it to the right 3 spaces. So it's going to go 1, 2, 3. Now you'll notice on my third space there is nothing there. There is no digit. So what do I do with that empty space? Well, you simply add in a 0. So the standard form of this number is 4,610. I had to add in a non-significant 0. Here is our next example. This time we're only doing 10 squared. So we're going to take our decimal and we're going to go 1, 2 places right here. We do not need to add any more zeros in because we have no blank spaces. So this number is simply 745.0. I do want to point out that this 0 does not get dropped. It must still be included in standard notation because it is significant. Remember, any 0 you have that is in scientific notation is automatically significant. So it must be included in the standard notation. Let's take a look at a really big number. Here we go right here. Wow, we're going to have to move this thing 12 places. Well, you can count out just like I did on my previous 2 examples, or you can say, well, I have 3 places right here, which means I'm going to need 9 more zeros afterwards. Again, use the way that makes the most sense to you. Here is our final number, and we can always double check this to make sure we have put in the right number of zeros by counting again. So my decimal point started here between the 2 and the 9, and I went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places to the right. Let's practice some now with the negative exponents. So here is my first negative exponent example. I'm going to have to move this decimal 2 places to the left. So I am starting here and I'm going to go 1, 2. There's my new place for the decimal point. But again, I have this blank space like I have seen before. So I am simply going to put a 0 there. So my answer is 0.0305. Always include a 0 here to the left of the decimal. This makes your decimal point much more visible. Let's go on to my next example. Here we go right here. This one is times 10 to the negative 7th. Now the way that I do these is I say, well, I know I'm going to move 1 place to the left here, which means I'm going to need 6 more zeros to make this 10 to the negative 7th. So I'm going to have 6 empty spaces going left. So my decimal looks like this. We can always double check. Let's count places, starting here. 1, 2, 3, 4, 5, 6, 7. For my next example, I have a really, really tiny number. This is 10 to the negative 14th. That means I am going to need 13 zeros in front of that 3. Here is my standard notation. Again, let's count and make sure that we put the correct number of zeros in, starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I definitely would not want to write this number with all those zeros in. For my final example here, I wanted to show you what to do with a 10 raised to the 0. So on the last slide, I showed you how to write that in scientific notation, now how to convert back. It's actually much easier because, of course, 10 to the 0 is the same as 1, so this is still just 3.8.
Now we can write those really large numbers or those really tiny numbers without having to deal with all of those zeros. And I don't have to worry about hand cramps anymore. I hope you found this video helpful, and thanks so much for watching.